Hey students, in this video, we start our new series of organic chemistry, okay? In this series, we discuss about organic chemistry from basic to advanced level. Now, what is organic chemistry? Organic chemistry is branch of chemistry which deals with organic compounds, okay? Now, what are organic compounds? Organic compounds are the compounds containing carbon, hydrogen, and oxygen, okay? Now, in old times, scientists believe that organic compound can only synthesize by nature. They believe that organic compounds cannot synthesize in lab, okay? But in 1828, the scientist Frederick Waller performed an experiment. He synthesized an organic compound by inorganic compound. He synthesized an organic compound, and the compound was ammonium cyanide, and he formed urea. Okay, now this is how our organic chemistry began, right? Now we see here our most important element of organic chemistry is carbon, right? So let's discuss some important things of carbon. Carbon has atomic number 6, all right? And electronic configuration of carbon is 1s2, 2s2, and 2p2, right? Now we see that the valence electron of carbon are 4, right? So carbon has 4 valence electrons. So to attain noble gas configuration, rather carbon have to lose this 4 electron or have to gain 4 electron. But it's very difficult to gain or lose 4 electrons. So what he decided? He decided to share his electron, right? He formed bonds by sharing of electron. Form bond by sharing of electrons. And the bond that formed by sharing of electron called covalent bond. Covalent bond. Okay, now next thing is carbon has sp, sp2, and sp3 hybridization. Now you must be thinking that what is hybridization and why we need hybridization, right? Why we need hybridization? Because by hybridization, we explain characteristics and geometry of polyatomic molecules, okay? So that's why we need hybridization. Oh, let's take an example of CH4. Now, by simply seeing the electronic configuration of carbon, we thought that carbon has 2 unpaired electrons. We know that carbon has 2 unpaired electrons, and we thought that carbon should form 2 bonds with hydrogen and form CH2. But in reality, this is very unstable. And in reality, carbon forms CH4. It means carbon forms 4 bonds with hydrogen. So it must be that carbon have 4 unpaired electrons. So how we make 4 unpaired electrons? To make 4 unpaired electrons, this electron have to excite in p orbital, right? Now we get 4 unpaired electron, right? We get 4 unpaired electron, but now s and p orbital have energy difference. So for bonding, energy should be equivalent. So we have to vanish. We should vanish this energy difference of s and p orbitals. So to vanish this difference by hybridization, we intermix the s orbital, 1s orbital and 3p orbital. All right, 3p orbital, and we get 4 sp3 orbitals. 4 sp3 orbitals, and these sp3 orbitals have equivalent energy. Okay, now these equivalent energies orbitals are called hybridized orbitals. All right, these have same energy levels. That's why we need hybridization, and stability of these orbitals are very high. These orbitals are more stable. Why they are more stable? Because in sp3 orbital, the electron repulsion tends to minimize, is minimum. Okay, that's why we need hybridization. Now you know that what is hybridization here? Hybridization is intermixing. What do we do here? Intermixing of orbital of slightly different energies, orbital to redistribute it, right? Redistribute the energies, and we get new set of orbitals having equivalent energies. All right, this is hybridization. Now we see that sp3 hybridization, arrangement of sp3 orbitals. Now you know that s orbital is spherical in shape, okay, and p orbital is in the shape of dumbbell, right? And carbon have 3 p orbital, 1 s orbital, and 3 p orbital in sp3 hybridization, right? We already see this, and we have 4 unpaired electrons and carbon bond with 4 hydrogens, right? And hydrogen only have s orbital, which is spherical in shape, okay? So hydrogen form bond with 3 p orbitals and 1 s orbital. All right, and the structure became like this. I tell you later what's the meaning of this wedge line, okay? This is tetrahedral structure. Now you get one thing, sp3 hybridization have tetrahedral geometry. Now similarly, we see sp2 hybridization. In sp2 hybridization, carbon have 1 s orbital and 2 p orbital, right?